Hello friends, this is the last lesson of the squares and square root series. In this lesson, we are going to look at a couple of examples of the applications of squares and square roots and how we can use them to solve problems. Let us look at the first example. So here we look at the application of Pythagoras theorem and how squares and square roots are involved in the calculation in Pythagoras theorem. So if you know the Pythagoras theorem, it states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the perpendicular and the base. So in this example, we have a right angle triangle ABC, where the perpendicular is 8 centimeters and the base is 15 centimeters, and we need to find the hypotenuse. So with the application of the Pythagoras theorem, we will see that BC square is equal to 15 square plus 8 square, right? So how much is 15 square? So ideally you should know this, but in case you don't, you can use our quick hack to find out the square of numbers ending in 5, which will, if you're not seen that video, I suggest that you go and look at that video. So in this case, 15 square will be 225 and 8 square is 64. So BC square is 225 plus 64, which gives us BC square as 289, right? So how much would be BC? It would be the square root of 289, which is here. So now, again, recollect our quick estimates of estimating square roots, right? So what is the likely units digit of the square root of 289? Since the 289 is a square number ending in 9, the likelihood of the square root should be either 3 or 7, right? Because 3 square is 9 and 7 square is 49, both end in 9. So the square root of 289 should end in 7. And here, also know that 10 square is 100 and 20 square is 400, right? So all the numbers between 10 and 20, their squares will be between 100 and 400. So 289, the square root of 289, therefore, should lie between, square root of 289 should lie between 10 and 20. We also know that 15 square is 225, which is closer to 289. Therefore, the number actually, square root of 289 should actually lie between 15 and 20. So in this case, it is likely to be 17, which is my guess. And if you compute through either the long division method, you will arrive at BC equals to 17. So in this example, we saw how squares and square roots are utilized in calculations in Pythagoras theorem and how you can utilize the hacks that we have learned to make our calculations really fast. So if you haven't yet seen that video, I again recommend that you go and see the video of squaring of numbers as well as estimating square roots without having to calculate. Go and see that. Let's look at the next example. So this is a problem I have taken from the NCERT book of class 8. So this problem states that the students of class 8 of a school donated 2401 in all for Prime Minister's National Relief Fund. Each student donated as many rupees as the number of students in the class. Find the number of students. So let us create an equation out of this. We need to find the number of students. So what do? We let us assume the number of students to be y, right? That's our standard method of forming equations. So let the number of students in y. And what do we know? We know that each student donated as many rupees as the number of students. Now, since there are y students, each student must have donated y rupees, right? So that is our next observation. Therefore, the number of students donated by each student is also y. Now, if each two y students donate y rupees, the total amount collected should be equal to y square. But we already know that the total amount donated by the school was 2401, which means that y square should be equal to 2401. So now our equation is created. So how do we find y? Yes, you're right. Y is the square root of 2401. So let us again apply our quick estimation methods. This is a 4-digit number, which means we'll have two 2-digit pairs. So we have 01 as the first pair, 24 as the second pair, which means our solution, which is the square root of 2401, should have 2 digits, right? So what is the first digit? The first digit should be less than equal to the square of the first digit should be less than equal to 24. So we know that 4 square is 16, 5 square is 25. So our first digit is likely to be 4. Also, know that look at the problem. The problem is asking you to find the number of students. So can the number of students be in decimals? No, which means that 2401 should be a perfect square, right? Such that you will not get an answer in decimals because number of students cannot be in decimals, which means that 2401 is a perfect square. So we can apply our quick estimation methods. So our first digit, I have narrowed it down to 4, right? Now look at the last two digits. The number 2401 ends in 1. Now, if the square ends in 1, what should be the square root unit digit? So remember, 1 square is 1, so it could be 1. And also 9 square is 81. That is also 1. So which means that our solution could mean we could have, as a solution, we could have 4, 41 or 49 as our solutions. So this is whatever I explained, I'm going to just now. So we have 1 or 9 as a potential unit digit. Now, how do we narrow down whether it is 1 or 9? What do? We take the first digit, which is 4 of our solution, right? And multiply it with the next number, which is 4 and 5, 20. Compare 20 with 24, which was the first pair, 24. Now 24 is higher than 20. If 24 is higher, we will go with the higher number, which is 9. So y equals 49. So with our quick estimation method, without having to apply the long division or factorization, we will be able to arrive at the right answer in a matter of seconds. You can confirm if 49 is the right answer by applying our quick hack of squaring two-digit numbers. And if you don't remember that, I suggest you revise it and you will observe that 49 square is indeed 2401. So this working over here is the application of the two-digit square method, a quick hack method, but I'm not going to explain it now. I suggest you go and see it. So in this way, you will be able to apply square roots to solving word problems and geometry problems. Let us look at the third problem. There are 500 children in a school. For a PT drill, they have to stand in such a manner that number of rows is equal to number of columns. So imagine number of rows equals to number of columns. What does it mean? Which means that number of children standing in a row should be equal to number of students standing in a column, which means that the number of students involved in the rows and columns, the total number should be a perfect square. So is 500 a perfect square? Doesn't look like. Why? Because we know that 20 square is 400, right? And 25 square is 625. So what we are looking at is a number between 20 and 25. So with an observation and our understanding of squares, we can actually narrow down our solution reasonably. So let us look at how do we go about it. So we need to find a perfect square number which is closest to 500. Because what do we need to find? We need to find how many children were left out. So if we find the perfect square closest to 500, the difference between that perfect square and 500 would be the number of children who are left out. So for this method, let us apply the long division. And let's see what kind of remainder we get. So square root of 500, what do we need to do? Yeah, we need to form the pairs. So let us 0, 0 is the first pair, remaining is 500. So now we need to basically arrive at a perfect square less than equal to 5 as part of our long division method. So which will be 2 square. So 2 square is 4. So 5 minus 4 is 1. Now we need to find a new divisor and new dividend as well. So we have 2 zeros remaining. So we get them down. So a new dividend is 100. Now let us find a new divisor. So we sum up 2 and 2. We get 4. Now we need to estimate the second digit of our divisor. So we know that 41 into 1 is 41 and 42 into 2 will be 84. 84 seems reasonably close, but let's try 42 into 2 and 43 into 3. Let's see which one is closer. So 42 into 2 is 84. 43 into 3 is 129. So our digit should be 2. So let us apply 2 and see what do we get. So 100, we get 84, and then 100 minus 84 is 16. So now we have run out of all the digits, right? So what does this mean? Which means that the nearest square closest to 500 is the square of 22, because 22 is our quotient, right? And 16, and that square number is lesser than 500 by 16. So if we do 500 minus 16, we should arrive at the perfect square, which is square of 22. And who are the students who will be left out? There will be 16 students who will be left out, because 16 is our remainder in this case. So 22 students will be standing in rows and columns, and 16 will be left out, who will not fit because that is not a perfect square number. I hope you understood this solution. So if you have any doubts, you can always write to me on ckvedic@gmail.com and I can help you out. Thank you so much.